Good morning, friends. This is Prabhu, Assistant Professor from RMD Engineering College. And in this video, we are going to see about some of the basic terms of units and measurements. So, as we all know, basic standard is maintained to measure the physical quantities. Say, for example, if you want to measure a height of a person, we used to express that with respect to centimeters, or with respect to inches, or with respect to feet, or something like that. So, there are some fundamental basic measurements required for different parameters. So, here we have listed some 7 major fundamental quantities. They are length, mass, time, electric current, then thermodynamic temperature, then amount of substances, and luminous intensity. So first, if we take the length, we are representing, normally we represent the length with respect to a standard unit called meter. And the second one is mass, that is kilogram. So we used to represent the weight with respect to kilogram. And the third one is time. So as we all know, time is an important parameter for measurement. So we are using it in our day-to-day life. For every hour, every minute, we are using this time. So it is represented with respect to seconds. And the fourth one is electric current. It is represented with respect to ampere. So the engineers, mostly the electrical and electronic engineers, we are regularly using this term called ampere. And the fifth one is thermodynamic temperature. So temperature is also an mandatory physical quantities of measurement. So it is represented with respect to Kelvin. And the sixth one is amount of substances. Say, for example, if you are getting some 1 kg of sugar, so there is a particular amount. So there is everything, there is an amount of substances which is represented with respect to mole. And the last one is luminous intensity. So luminous, in the sense, it represents the light intensity. So how far the light is coming, or what is the brightness. So everything is represented with respect to the luminous intensity. And now in this slide we are seeing about derived units. So there are two things. One is the fundamental units and another one is the derived units. So units that are derived from the base or fundamental units are called as derived units. Say, for example, if you take the length as a parameter, so length is something a fundamental unit, whereas if you consider an area or a dimension of a room, we have a formula: area is equal to length into breadth, which is nothing but an derived unit. So length and breadth are individually, they are the fundamental units, whereas if you consider it as an area, the area is derived from the length and breadth of the fundamental unit. So they are called as the derived units. So the example given here is volume. So volume always we represent with respect to cubic meters. So 3 parameters are involved in the volume. So that is why they are called as, we are representing with respect to cubic meters. So it is a derived unit. So here we can see about some international system of units. So it is an international standard created 7 units having special standards to measure. So already we have discussed about this 7 units, and some of the popular system to measure the physical quantities are given below. The first one is CGS, that is centimeter gram system. Okay, the first one is CGS, and the second one is FPS, that is feet pound system, and the third one is MKS, that is meter kilogram system, and the last one, that is the most important one, that is a SI system. Normally we used to measure everything with respect to SI system. So say, for example, if it is CGS, means centimeter, the length is represented with respect to centimeter, and the kilogram is the weight is represented with respect to gram. And if you take the second one, FPS system, the length is represented with respect to feet, and this pound, that is the weight is represented with respect to pound. And the third one is MKS, that is length is represented with respect to meters, and K is the kilogram. The weight is represented with respect to kilogram. And the last one is the SI system. So the next slide. This slide is a need for dimensional analysis. So what is the purpose of this dimensional analysis? So if you see the first point, physical quantities are measured using fundamental or derived units. So already we have discussed that length, then weight, everything are measured using the fundamental or derived units. So it might be a length or it might be an area, whatever may be, it's all represented with respect to physical quantities. Verify the next one important need for dimension analysis is to verify the equations and check their dimensional consistency. So we have to prove that. So say for example, if this is the square feet of a particular plot, means we have to verify with respect to some equations also. And the third one is helps in deriving relationship between different physical quantities. So this is very very important. So when we compare with two different physical quantities, then we have to know about some physical relationship. For example, we know 1 feet is equal to 30 centimeter or 1 meter is equal to 100 centimeter. So there should be some relationship between different physical quantities. And the last one is, however, consistency won't decide whether the given equation is true or wrong. The consistency is only not enough to prove that whether the given equation is right or wrong. And the last one is error in measurement. So normally the error cannot be completely eradicated. So always there will be some sort of errors that are present in a system. So occurrences of uncertainty in measuring a physical quantities are generally called as error in measurement. There are basically two types of errors. One is the systematic error and another one is a random error. So systematic error represents negative, or say for example, if you are going to buy 1 kg of sugar from a shop, the shopkeeper may give 1005 grams, or it might be 995 grams, or whatever may be. It may not be exactly 1000 grams. So these types of errors are generally called as static error or systematic error. And the second one is random error. So occurs irregularly and are not static. So they are not dependable. So and they are not definable. So we cannot define that this much error is the random error. So we cannot able to define them. So it might be due to a climatic conditions or temperature or pressure or whatever might be. So these errors cannot be exactly found out, but still to some extent we could able to predict them. So this is what called as the random error. So I hope this video will be helping you to have some basic analysis about the measurements and units. Thank you.